Hey guys, we are talking special case trinomials right now, and another special case that we have is difference of squares. Okay, so we're looking again this relationship with squares. How does that impact what I'm looking at? On your star chart, you would see a squared minus b squared equals quantity a minus b times quantity a plus b. So again, what does this mean to me? What does it look like? Why is it helpful to recognize this pattern? Math is patterns. All right, so let's talk first about what this pattern is. A squared is just telling us that this should be a perfect square. Remember, perfect squares, the square root is a whole number. So 9, 25, 36, right? B squared should also be a perfect square. You might notice, and we'll get to this, but you might notice I'm talking about special case trinomials, but there's not three terms. We're going to talk about that. Start thinking like, what is happening here? Why isn't there a third term? What could that be? What could that mean for us, right? All right, so let's go here on the other side, telling ourselves what these things mean. So A is going to be the square root of the squared term. And again, we're going to look at what this means with numbers because right now it's a little bit abstract, right? B, both places where you find it, B is the square root of our constant. Okay, and then if you'll notice, these are the same factors, right? We have A and B. So, but they just have opposite signs now. One's addition, one's subtraction. So everything should be the same except my signs. And we're going to see, I'm going to go through the long way first, and then I'll show what this pattern does for us, why we care. All right, we always look for a greatest common factor first. So 4 and 49, that's going to be 1. Cool, I like 1 because I don't have to change anything, right? But then I'm looking at this and I want to start factoring, but I'm missing the middle term. So I have to think, well, what do I do? Because the middle term is supposed to be the sum when I do my product sum puzzle, right? All right, so we are going to just rewrite this with the middle term. So 4x squared, if I don't see my x term, what happened to it? That means I zeroed it out, right? So I could put plus 0x. It doesn't matter, you could do minus x, minus 0x, right? And then minus 49. Hey, now I have a middle term. Now I have that trinomial, okay? So don't let it freak you out. If I have a squared term and a constant, that middle term went to 0. And so then the question is, well, how, right? Okay, so we're going to create our product sum puzzle. 4x squared times the constant negative 49 is negative 196x squared. The sum is 0x. So I need two numbers that multiply to negative 196, but add to 0. That tells me they have to be opposite signs and they have to be the same value. That means my product is a perfect square. So this is 14, positive and negative 14x. Okay, I could use Desmos. So that's what I know. All right, so I'm going to do this, build it out the long way, and then we'll look for the pattern, what is happening. All right, so I use product sum here. It doesn't matter where I put the positive or negative 14x, okay? So don't stress yourself out over placement inside the area model. All right, x times x. And now 4x, I could do 4 times 1. I could do 2 times 2. Looking at the rest of my puzzle here, I have 14. And I know 4 times a whole number isn't 14, so I'm going to try the 2. And if I'm wrong, I'll go fix it, right? 2x times negative 7 is negative 14x. 2x times positive 7 is positive 14x. 7 times negative 7 is negative 49. Beautiful, it worked out. So I'm going to do 2x minus 7 times 2x plus 7. Hey, somebody, guys, mathematicians are all about finding patterns, what works over and over again, so I don't have to keep reinventing it, right? So look at what we said when we broke this down, right? Square root of the squared term was a, square root of the constant was b. So if I look here, this is the square root of the squared term. So this is the square root of 4x squared is 2x. 7 is the square root of 49, my constant. I have two factors with opposite signs, and that is the pattern. When you have the difference of two squares, we're subtracting two squares, okay? So let's see why this is cool for us, because maybe I don't always want to do the long way. If I recognize patterns, I don't have to, right? So GCF is always my first step. For x squared minus 9, it's 1. All right, I look to see, are these perfect squares? Remember, it has to be perfect squares. Don't just go making up patterns that don't exist. So this is x times x, so that's perfect square. This would be 3 times 3. And it's subtraction. That's really important. This doesn't work for the sum of two squares. It has to be subtraction. All right, so if I know that, then I know my terms. I know my factors. So we're going to have x minus 3 times x plus 3, and I'm done. Okay, that's what difference of squares lets you do if you know the pattern, if you know perfect squares. Okay, don't make up any other rules. The pattern has to work. All right, let's do it again. 9x squared and negative 64. GCF is 1. 9x squared is 3x times 3x. 64 is 8 times 8. And we are subtracting, good. So there's my pieces. I should have two factors with opposite signs so that that middle term zeroes out. Okay, over and over again. Let's keep looking at it. All right, two more examples. 25 and 16, greatest common factor is 1. 25x squared is 5x times 5x. 16 is 4 times 4. It is subtracting the two, so I can use the pattern. 5x minus 4, 5x plus 4. That will get rid of that middle term. Just a side note really quick, just to convince you. If I were to multiply these out, there's going to be negative 20x, and there's positive 20x, which is where we get that 0, right? So just proving to you that, yes, this is why these are my factors. I'm not pulling your leg here, guys. I promise it's mathematically sound. All right, last one. First thing, GCF, so 36x squared minus 81. Both of those can be divided by 9. So I need to pull that first. I'm left with 4x squared minus 9. All right, and look how tricky, because 36x squared is a perfect square and 81 is a perfect square. But I want to pull out the common factor still first to be fully factored form, okay? All right, so I look here. That 9, I need to keep it. That's its job. 4x squared is 2x times 2x. 9 is 3 times 3. It is subtraction. So now I have my pieces. 2x minus 3, 2x plus 3. That would be my factored form. Don't lose that 9 at the very beginning. Okay, so that's difference of squares. Again, if you recognize the pattern, sweet. I don't have to go through the whole process because I know that when I have the difference of squares, I have this pattern that always works, right? So remember, it only works if the middle term is 0 and the other terms are perfect squares. You can use Desmos to check. You should have two factors, and the only difference between them is the signs in between, okay? So that's difference of squares. Look for the patterns.